Hi, there is Zmotion technical support. Today, let me show you Zmotion CAD mapping software usage with controllers. At first, let's see what we need. For hardware, we need one motion controller. But if you don't have the controller, simulators also can be used. Then prepare these well. For software, these two are required, and they both can be downloaded from our Zmotion website. Or you could contact us directly. ZDevelop is the programming software. Zmotion CAD is one CAD mapping tool. This CAD tool is used to generate processing codes automatically according to imported images. Then send codes to controllers and control axes to move the same trajectory. And there will be an example in the behind description. Here, it shows hardware wiring. According to this kind of sequence, connected to the controller, PC, and driver. And there are some details. Connect to main power, then use Ethernet to connect to PC. Then connect to drive. If your driver is pulse type, please connect to pulse controller. If bus, use bus controller. Now we have learned how to build the connection. Next, let's see how to map. Open Software. Find File in Software. Import graphics or open files. The graphics can be in these three formats. DXF file is generated by CAD drawing software. If you click Open directly, the file is Zmo file generated by mapping software. After opening, it will generate processing data automatically. If you think it is not so accurate, you could set manually and update it. Click this to regenerate the data. Then connect to controller and send data to controller. If you don't want to send the data now, you could save it. Click this or export to disk. During the operation, you can open ZDevelop and connect to controller. It can view the situation, but can't change the graphics. Okay, the basic step is over. Let's see the exact content of each process. Import graphic files. Click Import directly. Then one dialog box will appear. Select the corresponding file format. If the DXF file is imported, this software makes sequences for graphic data and generate processing images in graphics interface automatically. Also, if you are not satisfied, use custom function to manually set. If PLT file is imported, please select Drawing Unit. The default is 1016. Click OK directly. If AI file is imported, the data will be converted into units. Then process graphics. Anyway, whatever which one, all will be like this. There are 4 elements. Blue means processing trajectory. Green means empty motion. Arrow means the direction. Cross means the origin. And one importing operation only supports one file. If you need to import several files at the same time, please do several times of importing. Then generated images are shown in superposition form. When edited well, if you save them, they should be Zmo files. ZMO form is one form developed by Zmotion. It is used to show motion trajectories and motion properties, generally for absolute motion, except image file trajectory. It also saves user settings, and it saves in the form of objects and properties. There are many properties in objects. Property describes object. As we talked many, you can set manually. Let's see how to set. Click Set, Parameter Settings. Please see this. Axis number, speed, acceleration, and deceleration parameters can be filled freely. Then, Segment Precision. Segmentation means whether circle or arc needs to be segmented. Then, what commands you need to insert before or after motion. Here, the default command is Move OP. Click OK. Then the data is updated based on this setting. About segments, if you select No, circles or arcs will not be a part. If yes, please refer to the precision. if the precision is more than 1/2 of radius of one certain arc, or it is more than the 1/2 minor axis of one ellipse arc, then not segmented. See one example. Here select segment 1 arc, and the precision is 2 units. It is larger than 1/2 of small circle radius. So small circle keeps, but large circles will be segmented. And for basic code, it can be seen the small circles are the same. But here, there become 5 line commands to fix that arc. If the arc doesn't reach the needs, adjust the precision until it is accurate. Then export the code. For this part, before and after real axis motion, the default is move OP. Before, open the out 0, out 1. After, off them. One motion needs one inserting operation before and after. This. The parameter changes, and these global parameters are set, and they are shown here. Then, the position of origin. Origin represents the processing starting point. It also can be customized. Then basic code and bin data change with it. In this settings window, select the direction first. X, Y are defaulted as 0. Then set offset. After that, all absolute positions are changed. The origin offsets +5 in the X direction. Obviously, the origin is different, including the coordinates in the basic code. So the absolute position and empty motion length are different. No influence on relative motion. Except for coding, sequences also can be set manually. Click View, Custom Motion Trajectory function, and then in this window, sequence before and after changing both will be shown. The default sequence is number 1 because it is the first one processing trajectory. This one is the number 2. Then this is number 3. Change the number to change the processing order. Click the number once. It only shows the corresponding line as red one. Double-click it. You can change it. This greater than can reorder all graphics. All numbers will be passed to right. Then move up and down, top and bottom. Or even reverse, reset it. Then click OK. And if there are several of the same windows are opened, here you could switch. Please note this function is only valid in DXF files. Let's see the comparison. 1 to 3 becomes as 3, 1, 2. The big circle is number 3. Here, it is the first processing trajectory. If you need to change again, the initial sequence becomes the big circle is number 1. The line is number 2. The arc is number 3. And basic code changes correspondingly. This shows before, line, small arc, big circle. Then after changed, big circles, lines, small arcs. And the basic code is generated automatically. Then, when you meet the graphics and sequence, how to generate data? Actually, it will generate automatically when imported or open. You could view from the View window. And there are also 3 data types: basic, bin, or graphic data. They all can be downloaded into controllers. Bin data, it is G-code format. This is graphics data window. Bin data shows in G-code form. Before, we need to use GSUB command to define G-code subfunction. Then in GSUB, use basic commands to define G-code functions. Then call GSUB through G-code. At first, copy bin data into ZDevelop directly. They are used to call the corresponding G-sub function. Then edit G-code execution content through global G-sub. Like here, G91, relative positioning mode. G01, linear interpolation. Here, XY for passing parameters. X100 means the first axis moves 100. YO means the second axis moves 0. The program is scanned from up to down. When arrived, the corresponding subfunction will be called. For example, linear interpolation. Use move to execute the motion. When data are edited well, it's time to export and save. There are three formats: basic files, binary system files, and form data files. Actually, they correspond to the above three windows data. If you want to download the data into controllers directly, firstly connect to controller. Select correct IP address. No controller. Connect to simulator in ZDevelop directory. Then select this. After that, click here. Then there are three methods to download it. For our compressed packaging method, it needs to save basic files into local disk. This window will pop up. Click OK, and you only need to enter the file name. The suffix should be ZAR. When successful, this window appears. Then the system will download it into controllers automatically, and it runs immediately. And this, the motion trajectory moved by that basic code. When under XY mode, the same graphics in CAD. For Z3P method, it needs to save Z3P file into local disk at first. Then enter the program name of controller. Load the Z3P file into controller through Command or File 3 tool. Here, we save it into U disk and use File 3 run command as the task to call Z3P file. That is, only this is added here. Followers are file name and the task number. One means it runs as task 1. The last graphics are the same. For bin method, this uses flash blocking. Enter flash block number that sends the bin data. Then, the system sends bin data to controller flash automatically according to entered flash block number. But please note this method is only valid in controller connections. Okay, from now on, the entire CAD mapping process is over. Next, let me show other functions of this software. Simulation processing. Use visible speed to simulate the generation process. Red means it has processed. But during the simulation, the graphic is locked, which means we can't import or export images and can't change window position and size. If you want to exit, click Esc. Importing multiple files. Do you remember one importing operation corresponds to one file? If you want to import several files, please import several times. Then show them in superposition. When several are imported, all layers are shown. You can switch them here. Okay, in the next video, let me operate it in CAD mapping software for you. Thank you for your watching, and have a nice day. Goodbye.